All right, you guys, here it goes. Mr. Moss with 1.5 angle relationship notes for the last section of this chapter. I know that we, at least for the first half, part A, has already gone through some of these notes, but I'm going to go over them again for the beginning part to help out with this whole thing and define all that we have here, okay? Let me double check something here, see if it looks a little better. Looks a little bit better that we can see it. Okay, good. All right, so a couple of keywords here that we've got to make sure we understand is we're talking about adjacent. Adjacent means that it is next to, okay? Or in this case with geometry, it's because we want to share a common ray. Okay, so share a common ray are the two biggest things on this. So here's a couple of good examples that we're talking about. Now, adjacent means next to. I know in class with some of you guys have already mentioned it to you, is that next to, like if you were in a house and you have a next door neighbor and you guys share a common fence between your backyards. Okay, there's a fence that goes down. That means you are next to each other. That means you're adjacent to each other. Same thing if you live in an apartment. Most times will be a common wall that you are shared with another apartment that sometimes when people are a little bit loud and obnoxious, you can hear them on the other side of the wall. So it's because you share a common wall in this case. So when we look at this one, and we're looking at angles 1 and 2, this ray right here that's right down in the middle is the one that is shared, okay? That means that we know that angle 1 and angle 2 are considered to be adjacent to each other. So we're talking about this angle and that angle, okay? Whereas there's three rays, one of their own on their side and the other one on this side, and then the one that's down the middle that's shared, that's common, is considered to be so that these two angles are next to each other. Now, in this next example, it does show that we can have several different types of adjacent angles here. We have ones that are identified specifically here. So if we're just talking specifically about angle 1 and angle 2, this right here is a ray that is in between them. So that means that angle 1 and angle 2 are considered to be adjacent to each other. Okay. Now, if I were to throw in an angle 3 here, now angle 1 and angle 3 have an adjacent angle here between those two. I mean, a common ray between. So that means angle 1 and angle 3 are considered to be adjacent to each other. Just like angles 2 and angle 3, because it shares a common ray, therefore these two are next to each other. Okay, so I hope that gives you a general idea on that one. Whereas on the ones that are non-examples, it shows here that, you know, angle 3 and angle, whatever this angle here, could be adjacent to each other if we need to. But if we're talking about angle 3 and this angle here randomly, do they share a common ray? The answer is no. Okay, so therefore they are not adjacent to each other. So anything that's always next to each other will make it better for you that way. Okay, now, hopefully that gives you an idea about what we're doing, because linear pair has to do something. So again, looking at the example, we have again a common ray here. So we'll put common ray. Therefore, angle 1 and angle 2 are adjacent to each other. But in this example, we notice that we have something here, and I want to write down here as a linear pair. What does linear mean? Straight line, right? Okay, and that means we have two of them. So we have two of them that make a straight line. Now, when we have a straight line, we see it here. It's going to come all the way across like this. This whole thing is going to equal 180 degrees. Okay, so when we have a linear pair, they always make a straight line that equals 180 degrees. Now, there's also another name for this that we call it, and it's called not just a straight line, but a straight angle, okay, which also equals 180 degrees. And then later in this lesson, we're going to learn another word in here that's common for a linear pair. Is called supplementary angles. Okay, supplementary angles also together equal 180 degrees. But the key thing that you need to remember about a linear pair is that they have to be adjacent to each other. Okay, they have to be adjacent. Oh, see, I'm spelling it wrong. Adjacent. Okay, they have to be for a linear pair to work. Therefore, if they're adjacent, they're a straight line, or in their straight angle, that means they're supplementary. They also equal 180 degrees. So supplementary angles have to have two of them for that. Whereas in this one over here, if we were to draw an example, if I were to extend this one out, that would make it a straight line. Therefore, then we would have this angle and this angle, but we notice that that does not work. Same thing going with the ray this way. Does not extend all the way, so it can't be a linear pair because none of these are going to, if I were to extend them out, equal 180 degrees because they do not work that way, okay? So that's why that one isn't that way. Now, that one will be a good one that you need to learn because when we get into circles, that's going to be a huge thing to remember when we're dealing with half of circles, okay? Now, another common one that we're going to learn a lot about, and it's going to be one of your best friends, is vertical angles, okay? Now, this one's kind of a hard one to explain. I'm going to look in the book really quick and see what the book's definition of it, but I have my own definitions of it. Okay, so it says here that vertical angles are two non-adjacent angles formed by two intersecting lines. Okay, are two, okay, we can sit there in two non-adjacent, okay, angles. And they have two intersecting lines. And as you see in here, we have a line right here. And then we have another line that goes this way, and they intersect each other at this point in the middle. Now that means, if we were talking about vertical, a common word that I know and I like to use is called kitty corner or diagonal from each other, or whatever it might be. So we would sit there and say angle 3 and angle 4 are considered to be vertical angles. So we can sit there and say angle 3 and angle 4 are considered to be vertical angles. Okay. Now, a nice thing about this is what we could do, and let's go the other way too, whereas we would go, that means that angles 1 and 2 are also going to be also vertical angles. Now, a nice thing about this, and we talked about the word earlier in this whole thing, is that the word congruent. Okay. When we talk about congruent, that means angle 3 and angle 4 are going to be equal to each other, which is also congruent. So if I were to sit there and say, let's go, angle 3 is equal to 40 degrees. That means because it's vertical to angle 4, this one also equals 40 degrees. So we could sit there and say with vertical angles, we can call them congruent. Okay, and that's our congruent symbol there with the little squiggly. Okay, I got to get that on the screen a little bit better there for you. Okay. Same thing with angles 1 and 2. And I forgot to mention up here, which I'll go back and do, is that means angles 1 is congruent to angle 2. So that means this one would be 140 degrees. How did I know that it was 140 degrees? Again, going back up here where we talked about a linear pair or a straight line or a straight angle or supplementary angles, they all equal 180 degrees. Therefore, as you can see, this blue line is a straight line, which is again a linear pair of angles 1 and 3, and they equal a total of 180 degrees. Okay, so that one's also there. Or if we would go the other way, we'd say angle 3 and angle 2 again are supplementary or they're a linear pair, and therefore they equal, if we add them up, 180 degrees. Same thing with angles 2 and 4. Add them up, we get 180 degrees. Angles 1 and 4, same thing, 180 degrees. Therefore, we can sit there and know, again, your best friend of vertical angles is angles opposite of each other are always going to be congruent in this case. All right. So with that being said, let's go ahead and move down to the notes that we have here. Okay. And it says name. Let me move some stuff out of the way here. It says name to acute. Okay, again, we went back over these words again. So let's circle 100. This one. So we need this one. Acute means that it's what? Less than, right? 90 degrees, right? Okay, then the other word that we need to make sure we understand is that we're talking about adjacent. That means they have to be next to each other. Okay, so we got to find two acute angles that are not next to each other, or that are next to each other, and that they're acute, meaning they're less than 90 degrees. So let's look at this. So I'm going to go with this one here, and I'm going to highlight it in blue right here. So I'm talking about this angle right here. That one looks like it's acute. Now, we have a choice of being adjacent, meaning next to each other. Okay, so we have this angle over here that's next to it, and this angle over here that's next to it. Which one would be the one that looks like it's more acute than the other one? Yes, I would say that this angle right here is probably acute. So we want to name two of those together. So if we were to do this, this would be angle NJM. Okay, that's a funky thing there. Now notice that I did here, and I'm going to remind you when you do this, when we talk about vertices or vertex, remember the vertex always, the one that's the point of the two rays, always goes in the middle first. And the other angle that we mentioned also could have been angle, I believe I messed that up there. I hope it said O or a Q. We'll go O, J, N. Okay, so there's our two answers right there. But do we see any other acute angles in here that would be a possibility to consider? Yes, there is one. If we wanted to, because we identified this angle and this angle as the ones. But what about this one right here? If I were to do this one, could I have done that and got the same answer? Yes, that is true. So I could have also done where I could have done NJQ, but we're going to go angle MJL is also adjacent and acute to, let's go back here and we're going to go angle NJ and, whoops, I screwed up on that. That should be NJM. Okay, yeah, we got it right. Okay, good. So this one's a match and this one's a match. So if you had written down any of those two, we would have been okay with that. Okay, now, next thing we're going to talk about are what are words in here that are what? Obtuse, which means that they have to be what? Greater than 90 degrees in this case, and they have to be vertical. Okay? So as we do this here, and I apologize for all the colors in here, but I'm going to say this one looks obtuse to me. Okay? Sorry, the paper's moving a little bit. And this one is obtuse. Okay, so let's label those. So we'll go angle H, J, we'll call that O for right now. I hope that's the right one. And then we wanted to go angle K, J, and L. Now, what we talked about up here, and we show the picture up here that we mentioned, is that they are also congruent to each other. That means we could label them with a congruent symbol, knowing that, because we can sit there and say that this angle is congruent to the angle because of the reason of adjacent angles. Okay? All right. Any questions on that part? All right, let's flip the page over, see where we're at. Okay? We've got a lot of notes here today that we're dealing with, and we've got about 30 seconds before we're allowed to call this one quits. So we're going to stop there. I'm going to have you guys work on your part, and then we will continue on with the notes down there. Okay?